Okay, so I don't see a rush of people coming up the stairs. All right, let us get started. So, hi, I'm Liz Fong-Jones, and I'm a developer advocate at Honeycomb. And what I'm here to tell you about is kind of a little bit of DevOps 201. So there were two talks earlier that were DevOps 101, and I kind of want to bring people up to speed who weren't necessarily in those two talks, and then kind of dive into some of the more advanced aspects of DevOps, kind of more moving towards why are we doing it, how do we transform our teams, and not just the kind of basic tooling that you would expect out of a DevOps practice. So I do think that it's important, as was mentioned in the keynote this morning, right? Like telling your origin story kind of gives you a lot of context. It gives you context about where someone's coming from, what their background is, and what experience they're bringing to the talk that they're giving you. So I want to spend some time doing that as well as doing the level setting that I talked about earlier. So many of you here might think that production is complex and scary. And production sometimes seems that way, but how many of you thought that like learning how to code was once complex and scary? All the hands, right? Like, how many of you still think that code is complex and scary? All the hands again, right? Like, so it's okay to have some discomfort with this stuff. It's okay to have something complex and scary that you're wrestling with and trying to figure out, how do I do better at this? And the way that we do that is that we try to understand it. We try to get some of that context inside our heads to understand, how did this come to be? How do we make it better? And then we kind of start feeling more comfortable with it. So that's the journey that I want to take you on. I didn't always have a job as a systems engineer. I started my career as a support person. I was doing technical support. That was when I was 15. So I am a trans woman of color, and I also was disowned by my biological family. So tech was kind of a lifeline for me. It really saved my life. And the way that I got into tech was not through the kind of path of being a software engineer or being a systems engineer. I kind of got here through accumulating a bunch of skills. So the good news is, even if you think that you are a super hardcore software engineer, and you don't know how to do this system stuff, it's fine, you can learn it. Or if you have none of these skills, that's okay, you can learn it. So people might ask me, hey Liz, what are you really? Are you a dev? Are you an ops? And I have to say, you know what? I'm kind of a little bit of each, but at the heart, I'm kind of a support person. That's where I started, that's my family. And I think that dev and ops is kind of a false dichotomy. It's a continuum, right? There's a spectrum of skills in between dev and ops, and it's possible to keep both of them in your head. It's possible to learn both of these sets of skills. And also, I think that it's kind of an artifact of these false distinctions that people say, you know what? There's this dev camp and there's this ops camp. You may have seen this in the talk yesterday, right? Like, the dev camp wants to push faster. The ops camp wants to say, hey, slow down, I'm going to get fired if the site's broken too much, right? And I think that that's an artifact of the management choices that we've made over the past 15 and 20 years. And we can do differently, right? So that's why I want to encourage us to think about is, how do we bridge this gap? And how do we do it both with tooling and also by changing our culture? So that's what today's talk is about. So let's talk about the hypothetical example of Soda Co. I hope there's no one here from Coca-Cola. Let's talk about a hypothetical Soda Co. This isn't actually a reflection on Coca-Cola. I just put in a thematic fake company every time I visit a new city. So Soda Co. decided, hey, let's go buy DevOps, right? I want to buy a DevOps. I've heard this is a shiny new thing. Let's go make it happen. So they go and they order the alphabet soup, right? Let's get ourselves a Kubernetes. What's a Kubernetes? Or let's get us some continuous integration and continuous deployment because we need to ship more crap faster, right? Ship stuff faster. That's the only thing that matters, right? Or what about getting some pager duty? Let's put all of our software developers on call for the first time. That's going to go great. Like, if we just put the developers on call, it will magically solve this problem, right? Well, unfortunately, it kind of didn't go so well for them. What wound up happening was their engineers got super grumpy because they kept on waking up in the middle of the night. And they didn't actually have the time and focus to focus on making these systematic improvements to their service. They also had a problem with their dashboard vendor. They brought in this company that said, we will monitor all the things for you. Your things have never been so monitored. And you wind up with these automatically created dashboards that reflect every single aspect of your service, even the ones that aren't relevant to you when you get paged at 2 a.m. How many of you have had a wall of 10 different dashboards and you're searching for that squiggly line, right? Yeah, it's confusing. You don't necessarily need that, and yet that's what people who want to sell you DevOps in a box will sell you. But the core problem that they are trying to address didn't really get fixed when they adopted this, right? That even though they bought all of these tools, that users were becoming unhappy with the reliability level of the service. That people were leaving the company's service because of the fact that they couldn't order soda from SodaCo, right? So that's really kind of the core problem, that they bought all of this software not knowing what they were aiming at, and it didn't satisfy their real problem. And finally, I want to talk a little bit about the person who is the DevOps expert on your team. How many of you have the DevOps expert on your team? How many of you are the DevOps expert on your team? Right? So everyone stands in line and bugs the expert. The expert doesn't have time to document the things that they need to be documenting. And then you wind up with people feeling like super frustrated that they can't get their work done or they're too burnt out. And you keep on deploying all this stuff and it passes your tests. Your test board has never been greener, and yet your code breaks in production because you're not testing the intersections between aspects of your code. And you wind up just feeling burnt out. There's no time to do projects. You're feeling like you're juggling giant balls of fire all the time because you're just sitting there and pages are coming in and you don't have time to do anything but respond to those pages. And even when the pager goes quiet for a little bit, you feel like you don't know where to get started. There's no roadmap. You're just lost in the woods. And that kind of really sucks. So a lot of companies, unfortunately, when they buy DevOps, wind up driving their teams up the wall. It makes their teams feel like they're barely holding on. But I think there's a better way. I think what they're missing is starting from the beginning and thinking about what's the problem that they're trying to solve. The problem is that people are the ones who operate your systems. The engineers and ops people who operate your systems are human beings and they suffer from burnout, and you have to take care of them first. Your tools cannot accomplish magic. Your tools can help you automate things that you know how to do, but if you don't know what you're trying to accomplish, then no amount of tooling is ever going to help you. So instead, what we have to do is we have to invest in our people, our culture, and our process. So how do we do that? That's what today's talk is about. It's about production excellence. And it's about the art of making systems much more reliable and much more friendly to the humans operating them. But you don't get there by saying, you know, I bought a DevOps, now I want to buy a product. No. You have to plan. You have to develop that roadmap, and that's where I want to take you in this talk. So we have to figure out what are the right incentives. We have to figure out what are we measuring and make sure that it's actually what matters. We have to bring everyone on board, not just your dev team or your ops team, but also maybe, you know, your sales team, your customer success team, your executives. These are all important stakeholders that are worth addressing and including in your process. And you have to make sure that people feel safe to participate in the process. You cannot have a situation in which people don't give you feedback or people don't participate because they're afraid to ask questions. We have to bring each other's level up rather than just have the one person racing out ahead in front of everyone else. So how do we get started? I think that the 4 key things that you need to do is, first of all, know when your systems are too broken, be able to debug them, working together with other people when they are broken, and then to be able to close that loop and eliminate unnecessary complexity. There's always going to be complexity in our systems, but it's a matter of figuring out what's the essential complexity, what's directly related to the problem being solved, and what's technical and operational debt that you should try to pay down over time. So our systems are always failing, but I think that similar to how you might, not try to keep every single blade of grass in your lawns green and allow some amount of the grass to be brown, I think the same is true of our production systems. So we have to think about measuring what's too broken and only wake up humans if things are too broken. So that's the idea behind a service level indicator. How many people here have heard of a service level indicator? Okay, about a quarter of you, so let's go and level set everyone on them. So let's think about what's happening inside of your system, and specifically think about what is an event in your system. Maybe it is a user calling your API. Maybe it's a transaction passing through one microservice. Either way, what you have are events generated when traffic passes through your system, happening inside of the context of your system. So we have to go and make sure that we have appropriate visibility into that to understand what is the need of the customer. Is it being met or not? And therefore, is this individual event good or bad? Does it reflect the customer experience we want our customers to have? So one way of figuring this out might be asking your product manager. Your product managers might know, for instance, that maybe your customers start mashing the refresh button or they go away if your website takes more than 5 seconds to load, right? These are things that your product managers, that your user experience people, and even your customer success people especially know about. So figure out what makes users grumpy. And then figure out what's that threshold that buckets a good event from a bad event, right? So maybe it's that website takes more than 5 seconds to load. Or maybe it has to do with how long does it take from you swiping your card at a store to it showing up in your bank account as a transaction. So we might talk about things like error codes as well. Did the website show an error saying, 503 service unavailable? Or did it say HTTP 200, here's your web page? And then you have to go and add up, because every user's experience is the sum of all of their experiences over a long period of time rather than each individual interaction. So we have to find a way to aggregate it. And the best way to aggregate it is to think about adding up the total count of events that we saw, disregarding things like botnet traffic and other kinds of use cases we don't care about, and then dividing the number of good events by the number of eligible events to figure out what was our reliability level. And then we can set a target. For instance, we might try to set a target saying that 99% of my queries over the past 30 days will be under 300 milliseconds and return HTTP 200. So that might be one possible service level objective. And that lets us see in aggregate, how are we doing? How are we performing against user needs? But it's important to not set the target to 100%. Why? Because then you're wasting effort that could be instead be devoted towards shipping features that make users happier. So your good SLO should barely keep your users happy. If they see an occasional error and they hit refresh and it goes away, then they're not going to be calling up customer support demanding a refund, right? They're not going to be fleeing your service. And the cool thing is you can use these SLOs in order to drive your alerting. You can use the service level objective to say, I am going to only wake a human up if I'm in danger of having more than 1 in 1,000 user events be bad over the month, but not if one random hard disk is filled up to 90%. Because, oh my goodness, 90%. The disk is 90% full. How many of you have seen an alert like that? Almost everyone, yeah? And then figuring out things like, right, like how bad is it? Is my service on fire? And then looking at how long until I run out, right? If I allow 1 in 1,000 events to be bad and I get 1 million requests per month, then I know I can have 1,000 bad requests. And if I suddenly start getting 50 or 100 bad requests per hour, I know that I'm going to run out of my error budget and make my customers sad in the next 10 hours. Better wake someone up. So page, wake someone up if it's a matter of hours. But if you're going to run out of error budget in the next couple of days, maybe wait for business hours. It's okay to wait for business hours. That way you have less alert fatigue. You have your humans being much happier that they only get alerted for important things. And then you can also do things other than alerting. You can think about velocity. You can think about your product roadmap. And you can ask questions like, should I be moving faster, or should I be devoting more of my backlog items from my sprints into working on reliability? So for instance, I might ask, is it safe to do this risky A/B test? Well, if we've got plenty of error budget left, and we have a mechanism of reverting the test should it not work out, it's okay to serve some errors to our users. That might be okay. And then we can also think about reliability and thinking about, do we need to switch our priorities? Do we need to do that database multi-clustering? Well, maybe if our users are suffering because we didn't do that database clustering earlier. So you may be saying, Liz, this is unrealistic. You want me to perfectly measure every user's experience. Well, I'd say that that's a perfect SLO, but that is not necessarily the first place to start. It's okay to loosely measure your SLO where you can. For instance, maybe you have load balancer logs. Or maybe you have something running in JavaScript in your client's web browsers, right? Take some basic measurement and start from there. You don't have to be perfect. And then you can refine it over time. So measure what you can today, but then think about, how do I meet the user needs? Both through measuring things in a more sophisticated way, or if you discover outages that are not caught by your measurements, but also thinking about refining that target number, right? Maybe it's not 300 milliseconds. Maybe you discover that people wait up to 400 milliseconds. That might be an okay adjustment to make. Or discovering that maybe our SLO needs to not be 99.9%. Maybe we can go to 99.5% as a target. At the end of the day, what we care about is alerting only if users are experiencing pain. Everything else you can get rid of. But that's half the picture, because it doesn't matter whether or not you get told if there's a problem if you cannot debug it. So our outages are never identical. What helped you solve the last outage may or may not help you solve the next outage. And you can't predict in advance how things are going to fail exactly, right? It doesn't make sense to focus on a bug right there on the ground and then get turned around and surprised there's a big bug hiding behind me, right? So we have to be able to debug production and debug new kinds of failures that cannot necessarily be recreated in staging environments. If you're only stuck being able to look for bugs in your staging environments, you're going to have outages that are a lot harder to resolve and understand. So you have to think about, how can I form hypotheses? Can I develop a hypothesis like, maybe this is broken because when service A talks to service B, with this protocol version, it doesn't work, right? That would be a hypothesis. So you have to be able to come up with hypotheses in your head and then test them with real production data to understand whether they're true or not. And you have to be able to look at your data. You have to be able to dive into that data in order to ask new questions and get answers to those questions with your data. So in short, this is all to say that our services have to be observable. How many of you have heard of the word observability before? Oh, wow, that's much more than I thought. That's about half of you. Cool. So my own definition of observability is, can we understand our system? Can we ask new questions of our system in order to make decisions about our system without having to re-instrument or redeploy our system, right? That our system is producing enough telemetry for us to make these important business decisions. So in order to do that, we have to be able to go back to those events in their contexts. And we have to be able to understand what separates good events from bad events. Can we explain the variance between a good event and a bad event in order to help us test these hypotheses? And can we even capture some of this data so that we don't have to look at it in real time, but instead we can look at it after the fact and then understand what happened after it's already automatically been mitigated. So SLOs and observability go together. SLOs tell you when things are too broken, but they don't necessarily tell you what's broken. And observability helps you as a human figure out what's broken. But those two things aren't sufficient. You also need collaboration between people. Why? Because when you debug, it's not a solo activity. Often there are a lot of other stakeholders that you're working with. For instance, maybe you work on a team that works with other teams or has services that you depend upon that are operated by other teams. You also have to debug things in conjunction with people in other job roles, people who are working in your data centers, your cloud provider, or people from your customer success and sales teams. So debugging is really a thing that impacts everyone. It isn't just the realm of operations or engineering. And you have to think about those interpersonal factors, because we're not working with robots, we're working with real human beings. So we have to think about how do we foster collaboration between those people and make sure that they are not pointing fingers at each other, yelling at each other, or making each other feel like they can't raise issues. We also have to think about the human beings who are on the pager, right? How do we make things sure that things are sustainable? How do we make sure that people can keep on doing this job for years on years on years? One way of doing that is by reducing the workload every time that you get paged, right? Or every time you start debugging something. If you document things, then you are helping your future self. And you are sharing that knowledge that enables someone to become end-blocked without having to ask you. And you have to go and reward people for being curious, right? Instead of saying, oh my goodness, how dare you bug me about this trivial thing? Instead, maybe what you want to do is to say, thank you for asking that awesome question, right? It's clear that we needed to document this earlier, right? Thank you. So you have to learn from the past in order to make your future self's debugging easier. So I said earlier that outages don't exactly repeat, but they still rhyme, and I think that it's important to look at the patterns so we don't wind up working the same set of outages over and over and over again. One way of doing that is risk analysis. So thinking about how do we approach getting that feedback back into our system? How do we approach prioritizing what to do to make our system better? So one way of doing this is by thinking about how often do things break and how bad is it when things break. So we have to look at how often in terms of time between outages, right? So how often do we expect to have to, for instance, replace our database hardware? And then how bad is it if we have to replace our database hardware? Does it result in 100% outage for 2 hours, or is it we're replacing one node out of 50 and it takes 30 minutes? That has a big impact on how bad the impact is to your users. And then once you've done that analysis and cataloged kind of what's broken in the past in general themes and projected it out into the future, you quickly can see what things are the most important to fix. For instance, the thing where you break down under load every Friday because people are checking in code before they go home, right? Maybe that's something you want to prioritize because it's happening often and it's impacting a lot of users. And we can go back to that error budget, to that service level objective to see, you know what? This is not an acceptable risk because it's consuming a quarter or a half of our total error budget and leaving us no room for unknown unknowns. So we have to address those risks that threaten our service level objective in order to make that room that we need for unexpected things to happen. And fortunately, once you've gathered that data, it gives you a really concrete business case to fix them, right? If you know that your users start calling up sales and canceling their contracts if your availability dips below 99.9%, and you know that this failure mode is going to cause more than 0.5% failure, maybe that's something you want to address. And then, even if you've made the case to prioritize putting it on the roadmap, you have to make sure that you actually address it. If you don't actually address it, then you're just going to see the same kinds of rhyming outages happening over and over again. So prioritize completing that work. But I think above and beyond enumerating specific risks, we also have to think about the idea of systemic risks. What systematically stops us from being able to debug our outages? And I think that there are two important things that aren't necessarily individual line items, but instead impact every single line item. One of those is that if you don't have observability, that's a systemic risk. If you don't have the ability to debug your systems in production under load and ask those new questions, when you have an outage that you've never seen before, how can you figure out what's going on? If it takes you half an hour or 2 hours to understand what's going on rather than understanding within a matter of minutes, that's extra time that your system is down and your users are unhappy. So lack of observability is a systemic risk. But also, lack of collaboration is a systemic risk, because solving outages requires multiple people to work together. If they don't work together, if they don't communicate, then outages are going to last longer because they don't get reported fast enough, they don't get escalated fast enough, and they don't get solved fast enough from people putting their heads together to work on the problems. So it's okay to buy the alphabet soup, but I think you have to put a little dash of seasoning in it. I think you have to season your alphabet soup with production excellence by changing your people, processes, and culture. So production excellence brings your teams together, but you have to do that by measuring when things are too broken, being able to debug when things are too broken, and then collaborating on those problems and systemically solving those risks. So that's my talk, and I will take questions. Thank you. Yes.
For observability, not like to be language specific, but like what kind of tools have you seen that have been most successful at bringing observability into your, even just your ecosystem?
So let me repeat the question. So the question was, without being language specific, what ways do you have to improve observability that you've seen? Is that an accurate summation? Okay, great. So I think that there are a couple of ways to approach observability, and I think a model that works is to think about, can you instrument to gather the data that you need? Can you store the data in enough resolution for long enough? And can you query it, right? I think that those are that's the kind of core data workload. And one way of approaching that I've seen people do is, for instance, recording metrics or recording logs or recording traces, like distributed traces. But I think it's important to think first about what's the problem that you're trying to solve and then find the right tool to address it, rather than saying, I'm going to adopt metrics, I'm going to adopt logs, right? Like, you kind of can't start from the tools first. You have to start with what question are you trying to answer? What problem are you trying to solve? So, certainly I do work for an observability vendor. So I'm happy to talk about it after this talk. I try not to be too vendor pitchy. But essentially, I think that it's important to add the right instrumentation to your code, right? So you understand those user events I was talking about. Can you understand when they're happening? Are you emitting telemetry when a user event passes through your system? And then can you analyze it afterwards to figure out who's having trouble, right? Where are the 500 error codes in the system coming from? Does it make sense? Okay, I'm seeing a thumbs up. Other questions? Okay. Well, I will go ahead and give you 15 minutes back of your time. Thank you very much for coming.